we're very happy to have Douglas Crockford here, who is the creator of JSON and JSLint, and is also the author of a book called, as he put up, JavaScript, The Good Parts.
Good morning. Anybody ever heard of JavaScript? Anybody? A few hands go up. Not surprised that a few hands went up. It turns out JavaScript is the world's most popular programming language. There are more people using JavaScript than any other language. That's not necessarily something to be proud about. The previous holder of that title was Visual Basic. You could argue that most of the people writing in JavaScript shouldn't be writing in any language. I'm not going to argue that. But JavaScript is huge. It's obviously the language of the browser, and the browser has become the world's most important application delivery system. But it's also in embedded applications, it's in operating systems, it's in widgets, it's in television sets now. It's making a big move on the server, it's making a big move in mobile devices. JavaScript has become an important language. But at the same time, it is the world's most unpopular programming language. Ask any group of programmers, what language do you most hate? By far, the most common answer is going to be JavaScript. And in some cases, it's going to be because JavaScript is not the language that they know, and they're angry that JavaScript is more popular than their language, and really resent that. In some cases, they're writing in JavaScript and they hate it, but what they're really hating is the DOM. The DOM API or the web API is maybe one of the worst APIs ever invented. And it's not JavaScript, it's something W3C is responsible for. So it's pretty amazing being the most popular and least popular language in the world at the same time. One of the reasons why people hate it when they're using it is because they figure they don't have to learn it first. Which is not a mistake you would make with any other language, but for some reason people feel good about being ignorant about working with JavaScript. And it turns out JavaScript is based on principles that are different than most other languages, and if you don't understand that, it will bite you. Now, it turns out JavaScript has so much expressive power that you can actually get a lot done not knowing what you're doing. But that turns out to never be a good thing to do. Programming is complicated business. It should never be undertaken in ignorance. JavaScript is a language of many contrasts. It contains some of the best ideas in the history of programming languages. It contains some of the worst ideas in the history of programming languages. From the ridiculous to the sublime, there's no other language which has this extreme of qualities. Despite all of that, JavaScript is succeeding very well in an environment where Java was a total failure. The Java community doesn't like to remember this, but Java applets were supposed to rule the world. It was the biggest failure in the history of software engineering. So we see in JavaScript the broadest range of programmer skills of any language. We've got people, computer scientists, who are doing important research in this language, using this language. Some of the best programmers in the world are using this stuff. And we've got cut and pasters, people who don't even know that they are programming, and we've got everybody in between. Having a language which can appeal to either of those extremes is amazing. Having a language which appeals to both of those extremes is fantastic. And it's all this guy's fault. This is Brendan Eich, the creator of JavaScript. Very, very smart guy. At Netscape many years ago, they thought that they wanted to add hypercard functionality to the Netscape browser in order to allow ordinary people to write applications in it. Anybody remember hypercard? Yeah, some of the old timers raising their hands. HyperCard was a system developed by Bill Atkinson, used a simple card metaphor, and had a little scripting language in it in which all of the scripts were basically sets of event handlers. And at the time, event handlers were considered to be too complicated for doing serious programming, but the beginners didn't know that. And so they took to HyperCard and they were writing event handlers all over the place, writing amazing applications. And Netscape wanted to add that kind of stuff to the browser. Java was obviously not the language to do that because a beginner cannot write hello world in Java. You have to know way too much in order to get started. They wanted a language that people could just Go. So they interviewed Brendan Eich, who was a kernel hacker at Silicon Graphics at the time. And he was also an amateur language designer. He was getting ready to write a scheme interpreter. And they said, do you think you could do this HyperCard thing for us to the browser? And he said, yeah, and I think Scheme could be a really good language to do that. And they said, wow, this guy's really smart, so they hired him. Now, before he actually started work at Netscape, somebody at Netscape found out what Scheme was. And they said, no, you can't do Scheme. We want people to like this. So make it look like a language people like. Make it look like Java or Visual Basic or something popular. So he had to throw out his design. He started with a totally new design, designed and implemented a wholly new programming language in 10 days, which is, wow, an amazing accomplishment, and also really stupid when you kind of step back from it, like 10 days, really? So Netscape took that language and shipped it to the world as part of the web platform without ever having developed an application in it to determine if the language actually worked. So it went out with a lot of rough spots, as you would imagine. Smalltalk, by comparison, spent almost 10 years in incubation before it went public. Netscape spent about as many days in getting this language right. And so there's a lot which is wrong in it. So the influences on the design of the language, he took syntax from Java, because he was told to. He took functions as first-class objects from Scheme, even though he was told not to. One of the best ideas in the history of programming languages. I'll show you more about it in a minute. And he took dynamic objects with prototypal inheritance from Self. Self was a research language developed initially at Xerox PARC and then at Sun Labs, which took Smalltalk and tried to make it go really fast. And the way they did that was taking a risk approach to it. Let's remove the sources of complexity from the language so we can streamline it. The thing they decided to remove from Smalltalk was classes. They decided, you don't really need classes. We'll just have objects inherit from other objects, and that'll be much faster to implement. It turned out it also made it a much better language. That classes ultimately get in the way, and you can just make everything so much simpler by getting rid of them. And that was a surprising development. They didn't anticipate that. So Brendan took that idea, put it in this new language, and they called it LiveScript. And about the same time, Java was getting a whole bunch of attention. And so Netscape and Sun decided they should form an alliance, because if they didn't, Microsoft would play them off against each other, because they were both claiming that they had a platform that was going to destroy Microsoft. Now, the biggest point of contention, well, first, Sun said, you got to put Java into the Netscape browser, and they agreed to do that. And they also said, and you got to kill LiveScript, because it's embarrassing to have this other language here when Java is obviously the only language the world will ever need. And Netscape refused to do that for a number of reasons. One was because beginners can't write in Java, and they wanted to get beginners to write in the browser. So they're at an impasse, and the relationship almost broke down when Mark Andreessen, maybe as a joke, suggested that they call it JavaScript. And so they agreed to that. They had a press conference, and they went out and they said that JavaScript is Java's stupid little brother. It's a subset of Java. It's not very good, but it's there. And for a long time, people believed that, and there's still people who believe that. It turns out JavaScript has nothing to do with Java. They're completely unrelated except for some superficial similarity. JavaScript is actually the more powerful of the two languages. Microsoft took notice that there were these two companies in California who were getting ready to destroy it. So they decided they needed to buy a browser and get into this business. And they also decided to reverse engineer the JavaScript system and put that into their browser as well. Now, Sun, when they agreed to the name change, insisted that they own the name. At the time, Sun was shaking down coffee companies for daring to have Java in their URLs. This is true. And Microsoft wasn't getting along real well with Sun at that time, so they decided to call it JScript. A lot of people are confused about that, think it is two languages which are surprisingly similar. No, it's one language with two stupid names. Netscape was alarmed at that and decided we need to get a standard, otherwise we're going to get embraced and extended. So they went to the W3C. Now it turns out W3C had been waiting a long time for a chance to tell Netscape to go to hell. So they told Netscape to go to hell. So Netscape shopped it around and tried to find another place where they could buy a standard. They went to ISO, that didn't work. Eventually they ended up at the European Computer Manufacturers Association, which is a long way to go for a California software company. But ECMA agreed to make a standard. Netscape put one more condition on them. They said, you cannot call the standard JavaScript because that's a Sun trademark and we have an exclusive license to use that trademark, so you have to call it something else. At that point, ECMA should have told them to go to hell, but they didn't. So they put together a committee and they started working on it. And they very quickly produced a standard. Microsoft insisted that all of the errors that they had carefully documented and replicated that they discovered in the original Netscape implementation be preserved in the standard. So they're all in there. They tried to figure out a name for this thing. Working titles were WebScript and NetScript, but nobody could agree, so they shipped it with ECMAScript, which is maybe the worst name ever put on a programming language. And there are a lot of people who are still confused about what the relationship between ECMAScript and JavaScript and JScript are. It's 3 stupid names for one language. So let me show you some code. So here we're defining a global variable called names, and we're assigning to it an array of strings. We have array literals in JavaScript, which are amazing, and also object literals, which are amazing. And then I'm going to assign to another global variable called digit names a function, and that function, when called with a number, will return one of those names. Everybody with me? Okay. JavaScript looks very familiar, so even if you don't know JavaScript, this kind of stuff, you can kind of puzzle it out, and that's how most people do it. Now, the problem with this form is that names is a global variable, and global variables are evil. They have terrible reliability problems, they have terrible security problems. It might be in my web application that there will be some other code called names, and my array will interfere with that, and my code might fail or their code might fail. And it is impossible to test for that because I cannot anticipate all of the code that my code might ever run with. It's especially a problem if you have ads on your website because ads contain some of the worst script ever written, and they could have names which interfere with your names. Fortunately, JavaScript provides some means of avoiding the use of global variables. So here I've rewritten it another way. So digit name is still a function, and it now contains a private variable called names. And so that will not conflict with a global variable called names. So my program is now much safer. The problem with this is that every time digit name gets called, it's going to construct an array and put 10 strings into it in order to extract one of them. And that's going to be really inefficient. Now, an optimizing compiler might notice that names is invariant over invocations and might try to factor that out. But an optimizing compiler can take many minutes to do its job, and we cannot wait on the web. We want our applications to start instantly. And JavaScript is really good at that. The JavaScript compiler that runs in the browser is faster than the Java bytecode verifier. And that's a good thing, because one of the things that killed Java on the web was it takes a long time to start it. This morning, I started Eclipse. It takes 10 seconds to start. If Yahoo took 10 seconds to start, there wouldn't be a Yahoo. If Google took 10 minutes to start, or 10 seconds to start, there wouldn't be a Google. So we need to go really fast. So JavaScript compilers will never do that optimization. So I need to get rid of that time another way. So here's another way I can write this function. So here I've got a function. Again, I've got an array of names, and it returns a function. And that function uses the array of names. Okay, and what I'm assigning to digit name is not that outer function, it's the outer function's result, because you can see I'm invoking the outer function immediately. So what is assigned to digit name is the green function. And because of a thing called closure, that green function has access to the variable that was defined in the parent function, even after the parent function has returned. This is closure. This is all closure is. It's the best idea in the history of programming. And if we have a little time at the end, I'll tell you where it came from. It's a wonderful story and it's good stuff. And it's a thing that has enormous expressive power. We've got incredible control over the visibility and lifetime of variables. This works in factories, it works in object systems, it works in continuation passing, all sorts of callbacks. Everything we do is based on this. And it's unfortunate that it's called closure. I mean, it sort of comes out of the set theory thing. But most people think of closure as meaning retribution or vengeance. This is nothing like that. So anybody not clear on this? Let me go back to the original. So here, global, digit name, we have the same green function, and names means the outer, the global variable. So it has access to that. I can take this whole thing and wrap it inside of another function, and the relationship is still the same. So closure is all about nested functions, and that the innermost function has access to the variables of the outer functions. It doesn't have copies of those values. It actually closes over those values. It has access to those values, even after the outer function is returned. This is amazing. Closure. So writing an ECMAScript without understanding closure is like writing in Java without understanding classes. This is the fundamental idea, or one of the two fundamental ideas in this. Functions are first class in JavaScript, and functions are lexically or statically scoped, mostly. There are some bugs in ES3 which make that not true. It is much more true in ES5, and will be even truer in the next edition. So we can use closures to make methods, allow us to have objects with private variables, which is a good thing. So we can make a constructor function using this recipe. So number one, we make an object using any of the techniques available in the language for making an object. Step two, we define some variables and functions. These become the private members of our object. Step three, we augment the object with privileged methods. A privileged method closes over the private stuff. And step four, we return the object. So it's a little abstract. Let me turn it into a template to make it clearer. So step one, I'm going to make a constructor, and I'm going to have it create an object, and I'm going to put it in that. I'd like to call it this, but that is a reserved word. And I can use any technique available for making it. In this case, I'm going to call some other constructor, so that sort of gives me another dimension of inheritance. Step two, I'll create another secret variable. This is something that my methods will have privileged access to. Step three, I will create a privileged method and put it into that. And because of closure, my privileged method has access to the secret and to the parameters that were passed to the constructor. It also has access to that. In step four, I return that. This is a really simple way of making objects. It is really powerful. It has a nice property that, depending on how I construct it, I can remove a function from an object, and it still works. So I could then use it as an event handler or some other application, and I don't have to call a bind function in order to make it safe. So JavaScript has a lot of bad parts in it, but that's true of all programming languages. A programming language designer invariably will invent some new ideas and put them in, and some of them work and some of them don't. And if the language becomes popular, he cannot easily take them out, particularly if the language is a web language, because we're expected to be backward compatible. And once a mistake gets into the language, it's there for a long, long time. So it's been said only a madman would use all of C++. Some people would say only a madman would use C++, but I'm not going to argue that this morning. But any language can be made better by you. You have a power that the language designer does not have. You can choose not to use the language features which are problematic. And JavaScript has a lot of problematic features. And simply by avoiding them, you have a better language. So to help me do that, I wrote a program called JSLint. JSLint is a JavaScript verifier. It's written in JavaScript. It reads JavaScript programs. It will report all of the things in it which are bad. It defines a subset of JavaScript, the parts which are good and the parts which are easily verifiable to be good. Any feature which can sometimes be problematic, which cannot easily be statically determined to be a correct usage, JSLint says you probably shouldn't be using that. And it's free, just go to JSLint and use it, and it will make your programs better. But it comes with a warning. JSLint will hurt your feelings. I hear people whining all the time, JSLint, just fix your code. You know? Geez. So one of the things we can do with subsetting is make JavaScript into a safe language. Because it's built around lambdas, lambdas turn out to be a security mechanism. Because they define a scope and things declared inside of a scope are not visible outside of the scope, we can use that to develop secure programming. Unfortunately, we've got the web API, the DOM API, which is horribly insecure, and JavaScript also depends on global objects, which are also the root of insecurity. It's the root enabler of XSS attacks. So we want to be able to put third-party code into our systems, including ads and widgets and other things. And it's not safe to do that because any code that gets loaded into our page or JavaScript application gets access to everything, including access to our server and our local storage, our local database. All of that stuff is available to third parties. So an ad on a web page is a self-inflicted XSS attack. So AdSafe defines an even stricter subset of JavaScript, which doesn't allow access to the global object, which doesn't allow capability leakage, which allows us to say, we've got some code that came from a third party, we're not sure exactly what it does, but we can put it on our web page and be absolutely confident that it cannot cause an XSS attack. That turns out to be a useful thing. I've seen some people take the approach that we'll review all of the code that comes from third parties, that some human will have to read it and try to guess if it's going to become malicious or not. That turns out not to be tractable. So AdSafe is a safe subset of JavaScript. It uses static validation only, no code rewriting, so that the code that gets run is the same code that was written, so debugging and developer convenience. And because it doesn't rewrite code the way Google's Kaha does, there's no impact on performance. Another subset of JavaScript is the JSON data interchange format. The JSON data interchange format was inspired by JavaScript's object literals. JSON turns that idea into a language-independent data format. And it's a data format which is very closely aligned to the way we think about data in programming languages. So it turns out to be an ideal way of communicating data between different kinds of languages. It's documented with RFC 4627, which associates JSON with the MIME type application /JSON. I think it should have been text.json, but IETF didn't agree. JSON has no version number, so it's impossible to revise the JSON standard, which means it is stable. It will always be JSON. There are some things about the JSON specification which are not perfect, but being stable is a whole lot better than any change we could ever make to it. I expect that someday it's going to be replaced with another thing, but JSON will still be there. So if you're writing to JSON today, JSON should work till the end of time. There will never be a JSON 2.0 or 3.0 which is going to invalidate your current systems. And that's really important when you're trying to plug systems together. This is one thing you can count on. So the design rules for JSON were that it be textual, minimal, and a subset of JavaScript. So the things which might be considered mistakes in JSON came from the third one. But still, it's pretty good, and it works. And being minimal turns out to be really good. When I was trying to explain early on how JSON worked to some XML users, they were like, where's the huge tool stack that you have in order to make this easy to use? So we don't have one. We don't need one. It's just easy to use. Where's the stack? There isn't a stack. So JSON's simplicity comes from trying to be an intersection. There were previous data interchange formats that tried to be at the union. They tried to anticipate all of the different types that different languages have. All languages have strings, but the details of how strings work are different. All languages have numbers, but the details of how the numbers work are different. And they tried to solve that in the union. That turns out to be really complicated. JSON's in the intersection. So JSON says every language has numbers. So if you have numbers, you can represent a number as a digit or a sequence of digits and maybe a decimal point in the middle, and that's it. And it doesn't talk about types or bit encodings or whether it's decimal or binary or whatever. That's between the sender and the receiver. JSON just says that's a number. And that turns out to be an easy thing that everybody can agree with. And so it's really easy to move JSON from one language to another, even if they do not have common number representations. Similar with strings. A string is a sequence of Unicode characters. That's it. Can't have other encodings in JSON. It can't be Latin 1. It can't be Big 5. It's got to be Unicode. Booleans, true and false. Objects, which in different languages might be called records, structs, dictionaries, or hashes. Every language has a different set of these, but we can all agree that whatever we want to interchange, it's going to be this thing. And similarly with arrays, we've got vectors, lists, sequences. Every language has a different set of these, but for communication between applications on the wire, we'll do this other thing. So, in conclusion, JavaScript, or at least part of it, is a great programming language. And it is made even better by avoiding the bad parts. There are a lot of bad parts in this language. There are a lot of hazards in it waiting to get you. But you can simply choose not to use them, and in doing that, they cannot harm you. Programming is complicated business, should never be undertaken in ignorance, and don't check anything in until you've learned the language. A lot of people don't do that, and that's a bad thing. Finally, if you want to know more about the good parts, it turns out it's easy to find out what they are. Just get this best-selling pamphlet from O'Reilly, JavaScript, The Good Parts. So with that, thank you and good night.
Thank you, Douglas. Thank you.